Hello, welcome to our semiconductor education program. I'm Vincent Chang. I'm going to give you an introduction, a very basic concept about the semiconductor-based BJT and the CMOS operational amplifier. So it's impossible to cover all the knowledge, transistor level, and the internal circuit knowledge within 10-minute lecture. So the transistor level knowledge is beyond the scope of this lecture. And also a comprehensive understanding on the internal circuit of the OPAMP, including bipolar and CMOS, will be taught in other courses such as analog IC design. Operational amplifiers, symbol versus internal circuit. So this is the symbol of an operational amplifier, differential input and single-ended out. So for the triangle, I don't know if you think about this. What's inside the box? What's inside the triangle? What's inside the black box? Inside the black box is actually a very complicated circuit if it's based on a bipolar technology. So this slide shows a comprehensive operational amplifier internal circuit based on bipolar technology. So there are 24 transistors within this bipolar operational amplifier circuit. Each transistor is called bipolar junction transistor. Bipolar junction transistor have three terminals: emitter, base, collector, E, B, C. And EBJ stands for emitter base junction, and CBJ stands for collector base junction. It's the NPN bipolar junction transistor's physical structure. So for the supply part, as I mentioned before, you have the positive power supply, V positive, a negative power supply, negative VCC. On the top is the positive VCC. In bipolar technology, the typical value of the VCC is 15 volt. So here's the non-inverting terminal. The base terminal of the transistor Q1 serves as a non-inverting input terminal. The green one, the inverting terminal. The base terminal of transistor Q2 serves as an inverting input terminal. And here's the output terminal. So the output terminal is on the right. So differential input and single-ended out. Three terminals of the OPAMP. So on the left-hand side is the bias circuit, which includes the 4 transistors within the red block. Bias circuit. The purpose of the bias is to establish a constant DC current in the body of the transistors. So on the right is the input stage. It's called differential amplifier, consisting of 8 transistors. 8 transistors. And then toward the right is the gain stage. The gain stage. The typical value of this gain stage based on the bipolar technology is around 500. Gain stage. On the right is the output stage. So I just want to give you an idea. So you have the bias circuit, input stage, gain stage, and also the output stage. There are several topics will be taught in other courses. For example, the IC amplifier covers the knowledge of the integrated circuit bias and also the skill to analyze the differential amplifier. So if you are interested, you will learn the bipolar semiconductor amplifier to understand, to try to solve the input resistance, output resistance, etc., and also the voltage gain of the gain stage amplifier. So to understand how the gain stage operates, there's a capacitor, CC. So you need to learn how the basic concept about the frequency response and also how to analyze the frequency response of an amplifier. Also the feedback. So for the feedback, and such as low frequency and also high frequency involve the stability and also oscillation, etc. The last one is the output stages. So in a course such as analog IC design, you will dive in the whole circuit to understand how those sub-circuits interact with each other, and also the low frequency, high frequency, and the phase, the performance, etc. So I just talked about the first technology based on the bipolar technology. The second one is based on CMOS technology. So on the left is the operational amplifier based on CMOS technology. So let's call CMOS OPAMP. So there are 8 MOS, metal-oxide semiconductor. There are 8 MOS transistor within this CMOS OPAMP circuit. So each MOS, let's say the one on the right, bottom right corner called Q5, right? So the physical structure of the Q5 is shown on the right. So the MOS is the 4-terminal device, but usually the body terminal is not shown in the circuit. So source, gate, drain, the 3-terminal. Source, gate, drain. From the top to the bottom. The first layer is metal. The material below the metal is called oxide, and then semiconductor. So it's like the sandwich. So MOS, metal oxide semiconductor transistor. So 3 terminals, differential input, non-inverting, inverting. So the gate terminal of the 2 transistors, Q1 and the Q2, serves as the input terminal. And also the one on the right, the VO part, is the output terminal, differential input and single ended out. So for the CMOS OPAMP, it's the 2-stage. It's the 2-stage. The red block represents the bias circuit to establish a constant DC current. And there are 2 so-called current mirror within this red block. The first stage is similar to the bipolar technology, is the input differential stage. Sense the difference between the 2 input signal. And it's similar to the bipolar technology, the second stage is the gain stage. The comprehensive knowledge will be taught in more advanced design courses like the analog IC design. We are approaching to the end of this lecture. I want to let you know, when I was a college students first learn about the operation amplifier, I have no idea about what the triangle stands for. So the purpose of this lecture, there are 2 purposes. Number 1, I want you to make the connection between the triangle symbol, the OPAMP symbol, and the real stuff, the real internal circuit. So I said I didn't know this a bit when I was a college student. First learned microelectronics. No one told me this, but I hope you do. The second purpose of this lecture is give you a roadmap. What's coming up in the future? So what kind of material you can learn about the transistor level knowledge, and also about the amplifier knowledge, frequency response knowledge, and also the concept about the feedback, integrated circuit bias, differential amplifier, etc. And to put everything as a whole to integrate an analog IC design courses. Because operational amplifier is indeed one of the most important circuit system in analog integrated circuit. So this is the end of the lecture. Thank you for watching.